Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P16E2, indicates a PGM-FI-ACG LIN communication error in the Honda CR-V 2023 and newer models. This code generally arises when the Powertrain Control Module, PCM, fails to receive necessary signals from the alternator via the local interconnect network, LIN. The alternator plays a crucial role in charging the vehicle's battery and powering electronic components. The LIN is a communication network that allows various vehicle components to exchange data. If the PCM detects abnormal communication signals, it activates the DTC P16E2, indicating a potential issue within the circuit. The components involved in this error include the alternator, PCM, DC-DC converter, 12-volt battery sensor, and the shutter grille, all of which need to be inspected to diagnose the root cause effectively. DTC P16E2 reflects a failure in LIN communication concerning the alternator, primarily indicating that the PCM is not receiving the expected signals. The Powertrain Control Module, PCM, is responsible for managing engine functions and consequently relies on precise inputs from the alternator to assess battery health. The local interconnect network, LIN, facilitates data transfer between components, such as the 12-volt battery sensor and the PCM. When there is a failure in this communication, the PCM outputs a fault code. Locations to check include connector terminals at the alternator, plus B terminal, the PCM, and related components. Each of these parts plays a pivotal role in ensuring the electrical system operates smoothly. Failure in any might lead to power delivery issues. Several factors could trigger DTC P16E2. One common issue is a loose terminal connection at the alternator's plus B terminal. This situation can disrupt the communication necessary for the PCM to monitor the charging system. Another potential cause is damage or a fault within the LIN circuit, which affects data transmission between the alternator and the PCM. Additionally, a faulty alternator could cause the symptoms associated with DTC P16E2, leading to inadequate signal output. Identifying these problems requires thorough circuit inspection and possibly examining related components that may not be functioning effectively. When DTC P16E2 triggers, specific symptoms may become evident. Drivers might notice warning lights illuminated on the dashboard, indicating potential electrical or charging issues. Battery performance may start deteriorating, leading to difficulties in starting the vehicle or powering accessories. Additionally, drivers could experience unusual engine behavior, such as stalling or misfiring, primarily if the electrical system is compromised. Observing these symptoms suggests that further investigation is necessary to identify the underlying issue related to DTC P16E2. The first step in troubleshooting DTC P16E2 involves turning the vehicle to the on mode and waiting for 10 seconds. This process allows the vehicle's systems to initialize and may generate necessary signals in preparation for diagnostics. It is crucial to ensure that the vehicle is in the correct mode to maximize the accuracy of the tests performed thereafter. Be aware that waiting adequately can also provide an opportunity for the system to reset any temporary faults. This step is essential as it establishes a baseline performance state for subsequent checks and ensures that any ongoing faults are accurately identified. During the second troubleshooting step for DTC P16E2, it is essential to inspect the LIN circuit and verify the integrity of the connections. Start by examining the alternator connector, ensuring that it is securely fastened and that connections show no signs of corrosion or damage. The integrity of wiring within the LIN circuit is vital for effective communication. Any fraying or disconnects could lead to communication failures. If any irregularities are discovered during the inspection, they should be addressed promptly. Properly securing and verifying all connections can potentially resolve the error code and return the system to effective operation. The third step in addressing DTC P16E2 focuses on inspecting the alternator's functionality. Given the alternator's critical role in providing power and charging the system, a faulty component can lead to multiple issues. Use appropriate diagnostic tools to evaluate its operational status while simultaneously testing any related components, such as the 12-volt battery sensor. Identifying faults early in the alternator or its connections can save time and effort later in the troubleshooting process. If these inspections yield positive results, further analysis of the related components, including the PCM or the LIN circuit, is necessary. After performing the necessary repairs related to DTC P16E2, it is vital to conduct final repair verification. Begin this process by clearing the diagnostic trouble code using the appropriate diagnostic tool. Following the clearing process, it is essential to recheck for any fault codes to ensure that the repairs resolved the issue. If DTC P16E2 or any other related codes are still present, further inspection may be necessary. This step confirms that all systems are functioning correctly and that communication among the alternator, PCM, and LIN network is re-established. Successful verification indicates that the troubleshooting and repair efforts were effective. To prevent future occurrences of DTC P16E2, regular maintenance becomes essential. This includes routine checks of electrical connections, particularly at the alternator and PCM, to ensure integrity and to mitigate issues from loose or corroded terminals. It's beneficial to implement a schedule for inspecting the alternator's functionality, especially after major repairs or heavy usage periods. Keeping track of battery performance and electrical system operations can help catch minor issues before they escalate into significant faults. By prioritizing these maintenance tasks, vehicle reliability increases and the likelihood of DTC errors decreases. In conclusion, DTC P16E2 signals a communication error involving the PCM and the alternator via the LIN network. Understanding the roles of the alternator, PCM, and associated wiring is crucial for effective troubleshooting. By systematically following outlined inspection and troubleshooting steps, technicians can accurately diagnose and resolve the problem. It's essential to address any identified issues promptly to prevent electrical system failures. Lastly, by adhering to preventive maintenance protocols, vehicle owners can significantly reduce the chances of running into similar issues in the future, ultimately ensuring a smoother and more reliable driving experience. Please like and subscribe to the channel. See you next time.